I'm going to make a test to see how well this is going to work. We are now talking online. Okay, I want to see if this is going to work. I see the microphone is picking up. It says use mic and speakers. So I wonder if we're talking, if this is really working. See media USB. I can move things around. I can close this. I'll stop recording. Greetings. Good morning. This is Doris Laird. I hope you guys can hear me. I can see the microphone working. It's 10:30. The reason you guys can't talk, because if you do this on webinars and you have 30 people talking, all you hear is a lot of noise. So I'm going to have to wing it. It's sort of speaking into the darkness. And at the moment, let me turn on show on the screen. It says on air, showing screen. Now you guys can ask questions. There's a panel under there. You can ask questions and show answered. And I'd like to save the questions toward the end, at the very end. And you guys should be able to see the topics for today. It's a technical seminar. This is not a demo. So it may be a little slow at times. I'm going to try to go fast. I am recording it. So, and that will be available after the seminar. I have to upload it. It'll be quite large. So I'm going to jump in. It's 10:31. And if you guys can't hear me, you can go ahead and send a question in and say, hey, it's not working. There's also a chat. But I'm going to assume we're all together. I want to talk about the FEMAP and NX Nastran learning resources, how you would find out more information on how to use the program. Touch briefly on the mesh toolbox, and then jump in and talk about solids and surfaces. FEMAP, they treat them the same. They're both parasolid entities. Surfaces are considered infinitesimally thin solids, so you can use the solid commands on surfaces. Introduce manifold versus non-manifold, working with geometric surfaces. Talk about the application programming interface, and customizing FEMAP. That's our agenda. Meshing. The foundation to every good model. This is a winch for an offshore oil drilling platform. This is the gearbox. There's four, I believe, 1,200-pound motors hanging off the end. This total model is 112,000 notes. One of the things you can do with the new FEMAP, you click on this, show model data, plate element thickness, and you can see what's going on for the thickness. Let me turn off filled edges like that. It gives you a graphical representation of thicknesses in your model. And okay, I went over to visibility. Let's go back to this and turn this off. Okay, so this is one example of quality meshing. This little model is super efficient, 50,000 notes. And the reason why it was set up like this is all FRP, composite, honeycomb, and nonlinear analysis was done. This is steel. We have some brick elements. Very numerically efficient, very fast. And this is a pressure vessel setup. You can see all the map meshing. The total model, if I turn right-click, full model, 100,000 nodes in the lower corner. Good. Okay. Well, we got 24 people here. I'm assuming it's all good. I'm not seeing questions. You can see. Okay. Let's refresh on the toolbox. I know there's still people out there that haven't seen this. I'm going to use the selector, surfaces, select multiple. It's Windows. Shift key down, draw. It loads all these surfaces into a selector. Then if you right click, it brings up this other menu. Mesh size. Let's see what 5 would look like. That's a little too coarse. If I just touch, it says, we'll go back to surfaces. Right click, mesh size. I'm going to use the default. I'll touch it again, back to surfaces, right click, mesh, and I'll throw some plates on it. One thing to note, when you're in the entity selector, the right click is it says, oh, I'm in the selector. It's going to do this. If you don't want that, if you go Alt, hold the Alt key down and right click, it brings up the normal menu. This stuff is on online help. You know, I started showing the models and I got off message about, okay, learning FEMAP. Using toolbars, all these dockable panes. This is very good information. They've spent a lot of time working on the FEMAP help. If you go into it, you can see you have your examples. It's a good place to start if you have questions on doing something new. Also, under more resources, everything up here in HTML is in PDF format. And I like to use the PDFs just because they're more compact. That's on that. And also, where is my Chrome? There it is. Some of you guys might have seen this website, resources, tutorials, and downloads. I also have a section dedicated to the application programming interface. If you click on it, you'll want a password, predictive, and this is all in my email signature block. You see the password and stuff. And so you have FEA course notes, and you also have tutorials, and you have also new user, just basic stuff. So there's some information for getting started using FEMAP. Back to the toolbox. I'll click this off like this. Let's go in, meshing toolbox. And these are panes. You see how I have it set up. And I'll click right there and lock it back in. I like switching between model info and meshing toolbox. Meshing toolbox, I want to auto remesh. So when I make changes, I want it to automatically update the mesh. I'm going to combine some composite curves. No, I don't want to do that. Where is it? Ah, that is combined boundary surface. Add, here's the selector, because we have sort of a bonus surface there, and I'm going to combine that, and that merges that together. Then, to make for better meshing, I want to simplify the curves. I'm going to join this I'm going to make it into a 4 curve surface. You see it's updating. Then I'll go on here, and it's going to add. I'm trying to see what I'm doing. It's going to add by 1. So if I go to the selector, look what it's doing in entity info. This is another one of those cool little panes. I have it tabbed here. So it's in curves. The selector's curves. It's going to update it. It says there's 12 there, 7 there. So I'm going to make this, I'm going to make it 4-sided. 9, I'm going to subtract. This down to 9. Voila, and add 5. Let's make this 5. There you go, perfectly meshed, high order elements. The reason this is important, on plate elements, any sort of element, isoparametric element, 4-sided tetrahedrals, 6-sided bricks, plate elements, is that the perfect element is 1 by 1. And for a solid, it's 1 by 1 by 1. You get perfect integration, perfect matching of stiffness. It's absolutely guaranteed the best stress results. Every time you deviate from that 1 by 1, the element starts to degrade. Yes, you can add a lot more elements to your model, and that's typically what we do, but there is a limitation of how much you can add. 8, and my preference is have better looking elements. You're going to get better results. So that's the toolbox. Okay. Parasolid geometry, solid and surfaces, manifold versus non-manifold. Back into here, surface modeling, not manifold. By the way, along with the AVI movie file of this session, I'll have all the geometry files. So if you want to replicate using the geometry, you can, no problem. Let's go back to there. Group, operations, generate by solid. This is a bus seat from Navistar. Came out of NX Graphics. All plate model. Yeah, you could TED it. You could turn it in tetrahedrals, but it would run in your lifetime. And even if you did, the results would be questionable because it's such a thin section. Really, there's nothing like plate modeling. So we go in here, show active. Let's make it active. And I want to add automatic add. I want to, when I make operations in here, I want it to add to it. In this geometry, to turn it into a thin section, and this is going to be manifold because it's continuous. You can follow all the way around. There's no bifurcations. I think of manifold sort of like letters. The letter C is manifold. The letter D is manifold. Things that aren't manifold are non-manifold, like A, B, the letter T. So things are smooth and continuous are called manifold, and are really simple to mid-surface, more or less. If you try to use automatic, which is the default, this geometry is very problematic, very difficult to get a mid-surface out of. And that beget offset tangent surface. It wants a seed surface to start off with. You see the picking here? I'm going to right-click, pick front. I'll just pick whatever is in the front. And it needs a little bit more tolerance. And of course, you could always do F1 and look at the FEMAP online help. It'll automatically determine the offset distance. And it'll do another thing too. It'll stitch all the surfaces together into one body. Dun, dun, dun. Tangent right there. If I turn on the highlighter. There. So that's one geometric manifold skin. And from that, it's very easy to mesh. You immediately save yourself lots of problems with matching up curves and things, surfaces hanging. So. Okay, now I'm going to get into actually a little bit more detail. Let's go up and go back down. Simple little part, came from a client to mid-surface and turn it into a decent looking mesh. It's just a structural bracket, and it fits into this space frame structure. And beautiful model. Turn on filled edges, turn off the thickness. You got beam elements, rigid links. Here's all the plates. Super numerically efficient. And it looks good too. I'll close that. Back to here. Mid-surface, automatic. Select it all. It wants to know the thickness because it's going to fit a skin between these two. I can use this helper. Right click to snap to point because I want to snap between. I want to measure the distance between these points. If I double click, it's okay. It loads it and okays. There it is. There's that. If I look to the tree, it's going to tell me what are the two solids. And the rest are all these mid-surface skins. I'll just go delete them. And these are manifold. We have two manifold skins. So I'll go to the solid. I'm going to stitch them. I went slice. What was I doing there? Stitch. Select all. Default tolerance. And you can use this to clean things up. If you have geometry that doesn't match up right, you can get it to merge to seal. This is giving you feedback and it's saying this solid is not connected to this solid. You have two independent stitch bodies. So it's taken all those individual surfaces and turned them into individual sheet solids. So they're all connected. These two, they're not connected together, but they're each independent. Now let's turn it into an analysis model. We have a gap from here, and we want to close up that gap. So we're going to go to Geometry, Mid-Surface, Extend. Pick those curves. And we want to make sure that we got the right curves. We'll hit the highlight. The default says extend to a solid. It doesn't work because of this curve down here. It's not a perfect world. I hit previous. Now I'll just say distance, and I'll just give it 2. I don't really care. It extends in. Solid, I could do it by intersect here, or I could do it by mid-surface and intersect. But if I just pick these by intersect, there's our 2 solids. That slices it. And they're not quite equal there. we'll just go to solid, slice, take this. I really don't want to pick 3 points. I know there's a better method. Global plane, X, Y. The snapping to points, it's just, see how it returns that point? Just click, because I have snap to point enabled. That's going to slice it. Now I can go and delete some surfaces. Right click, take the front. You can do the right click when you're in a box, when another box. Got some hangers. I think I got everything. Yep. Got rid of that. This is not uncommon. You have these curves hanging from a prior operation, and you can get rid of them because it's redundant geometry way at the bottom. It's one of those things. Unless you suffered a little bit, you might never know this. Clean up. Let's clean that up. Let's get rid of that redundant geometry. Boom. Done. Now, we still have 2 pieces, and meshing could be difficult because lining these 2 up and fighting with that. This is a wonderful tool. I use this all the time. Non-manifold add. What's this? Voila. It seals them. You now have one general body. Gets rid of all your meshing problems. Joins up, sealed, it's happy, connected, congruent, all set. Now, to make for better meshing, you can look at this and, well, they give you plenty of tools to work in your geometry. We just say, okay, let's go and select multiple, use the default. Got ahead of myself. Select, mesh. And I'll do a lot of very simple stuff like this just to see how things are looking. It's not so bad. I mean, it's not ugly, but we can do a lot better. I'm going to undo, Control Z, and now I'm going to sort of force it into being a better mesher. And that is where you use all these. These are all your power meshing tools. With these, you can get away with everything. A lot of these tools are going to be integrated into the meshing toolbox for the next release so that you can take your mesh and you can do all these updates on the surfaces. And what you're doing is you're imprinting over your infinitesimally thin solid. It's still a solid. You're just breaking it into more surfaces. It's very useful. I don't want to pick on that. That's actually curves on surfaces. This will split the surface. It will update the surface. So our first step, curve washer, 0.1. And you only need to pick one curve on each. I think everyone has sort of seen that. Now, I want to force it to be better behaved in that I'm going to put a pad onto it. And this is the diameter. Pad size will make the pad 1 time default is 1 times greater than the diameter of the circle. And I'm going to pick on the outside like that. And that puts a map mesh. It forces it to be perfectly quad around there. Now let's see what it does. Make sure I have all because I have new surfaces in there. Use the default, place on hold. Click again. You see the workflow can be really fast. You're not having to move the mouse a whole lot. And don't be surprised. You get stuff like this and you go, what the hell is that ugly mess? It's because that is not a map mesh. When it creates those washers, it doesn't map them. That was a little command when it says set up map meshing is what it's doing. Well, let's do that. Let's set up our approach. So we do get mapped, meshed. I pick them, approach, and mapped. And you don't, this is in 10.1.1. You don't have to assign that. It knows. And that command, mesh control, right there. Because it's on surface in the selector. When you're working in the selector, it says, what are all the things you can do with surfaces? So approach is buried mesh control down there. Okay. Now if I go in the toolbox, update, you're going to get some, since it's mapped, it's hooking everything up. And add by one. Watch this. Okay, right now this is set to 5 and 5, 5 and 4. When I click here, it's going to propagate it out to the other mapped. And I'm just sitting there bumping it back up until I get something that I like. Not bad. So that's on 21. So then I could say, I'll set everything to 21. Use this here, dialog select. Voila. Much nicer. Clean. Then since these are mapped meshing, say that fast, go back to here. If you pick the one curve, notice how it propagated through and updated the others. Likewise, if you wanted more there. There. So with a few clicks, not bad time, you get really a beautiful mesh that you can do things with. Okay, that takes care of discussion on manifold geometry, continuous, smooth, non-manifold, using the toolbox, using the selector a little bit. I know people don't like using it, it's sort of hidden. You know, the general modeling, using switching between meshing, auto info, meshing toolbox. I know this is one of the interesting stuff. Where am I? Let me close that. We get so much stuff loaded up. If you go to elements by type, you can turn things off here. Get rid of the beams. There's a lot of functionality in viewing and visualizing and working with your model in the tree. And there's going to be more stuff coming in the future. Now I'm going to talk a little bit about using the API. Interesting. I haven't seen a crash in a long time. Huh. Wow. Also, I want to say something. If you guys are seeing crashes, let me know. Or things that aren't working correctly, definitely let me know. Send me an email, advise, because we can get it fixed. If the developers don't know about it, they can't fix it. So, okay. I want to talk about using the API. It's something that we have dedicated resources for teaching, for getting people started. Tutorials. I have a staff engineer. I gotta admit, I hardly know anything on it. And these are all the standard APIs that we have set up. They're just a fraction. And this is my list that I've set up a custom menu. And the way you set up a custom menu, customize, commands right there. Just drag it up. So these are all APIs, and they can be programs too. APIs, it's a visual basic. If you've never seen it before, it's under programming API, and it comes up a little visual basic. And I keep mine in one place: geometry processing, importing, exporting data, translation, beam, calculated beam stress. No stress export. It gets a little there. I try to document what's going on, dim, and it's just Visual Basic. If you know it, it can be quite easy to use. What can I say? I don't know it. I have my staff engineer to figure it out. So we're going to do a little pressure vessel. It's an API, and it creates a mid-surface, all ready to go. And that can be your foundation for building whatever you want. Now I got to go back up to here, web meetings, drilling back down, why the API is useful. Well, there is a lot. This is where I got to for this little demonstration here. Has some stiffener rings, a couple valves coming into it. This is a bolted flange, and we want to put bolts all the way around this flange. And in the tree here, we've defined a bolt property, so it's ready to go. This is another connection elements on curve. So I'm going to double click, which is loads it and hits OK. Second curve, starting point. It wants a point. I'll zoom in a little bit. There we go. Inner spacing, 2 inches around the bolt circle. The property is our bolt, and since it's a beam element, it needs a direction. I'm hitting return and tab and enter. And it goes in, creates our bolts, and like that. I can turn on the thickness, and it breaks the curve. It's an important distinction because it breaks the curve and it gets it ready for meshing. So when you mesh, you're guaranteed to have a node sitting right on top of your beam element. And yeah, it doesn't do the element right on the point. I forgot why we had that set up like that, but there you go. Analyze. And now you know how I did this. This is a pad set up here. And if I didn't like that, I could, of course, go to the meshing toolbox. And I could say, auto remesh, please. Mesh sizing. Add. Just going to do it by 1. I could make it a lot tighter because that's a pad around a curve, things like that. But I don't want to do that because I have pressures applied on the back. Yes, it's not the prettiest mesh there. I did have to. I do have other things to do instead of making, but that is very, very nice. I mean, this mesh took me no time. I just basically threw it together, and I could clean that up too. Okay, with our results, right-click, contour. Okay, yes, let's go to post data. Plot. Since we're dealing with plates, we want to look on both sides. I hope you guys saw that. Contour options, element, because we want to use attributes on the elements to help us contour the data. Like don't contour between properties and angle. Use double-sided. So there is our von Mises. If you do pressure vessel work, you don't want von Mises. What you want is stress intensity. And you also need the membrane stress. So we have another API here. And this is just another program. And this one is huge. This took far more time to write than I'd like to admit. It was a little bit scary, but very useful. It has saved so much effort. Just insane. Well-versed investment. So if you go back down to post data, now you have your stress intensity, which is a little bit higher than your von Mises, and you have the membrane stress. Another term for this is stress linearization, like that. Now to extract forces, oftentimes we've run into this requirements where you have these constraints. They want to know, okay, what is the summation of just your reaction force at that point? Some SVC constraint force. We can pick all the nodes right there. And let me turn off messages. I'll lock that back in. And we have none. Oh, I know why. Because, that again, and I got to pick the right case. There we go. So you can walk around, you can use that API. This one actually has a lot. Bolt stress calculator. So I want to take out output set 1. Method type, beam elements are type 5. You do that. If you guys are working with bolts, you know that taking beam stresses, taking bending stresses when you're using them for bolts is problematic. So this generates axial stress, and it also generates a pseudo von Mises stress for bolts. It's taking the shear stress of the bolt, and it's taking the axial stress, like that. There's your default. Okay. So in a half hour here, what we've done is we've covered learning resources, toolboxing, Parasolid, the API, creating toolbars, making your own custom API bar, and I think you guys probably know how to do customize toolbars. You can make new. It comes up and you can move them around, and then you can load it with tools, things that you use on a common basis. It's that easy. And usually if I'm doing a lot of hex meshing, I'll make a custom toolbar for hex meshing to cut, slice, and operate and things like that. There's quite a bit of flexibility you can do within FEMAP. At this stage, I'm trying to keep these webinars short, fast, cover a lot of ground, get the information out, and that I've covered up the main information. So at this time, if you guys have any questions, you can go ahead and load in questions and I can answer them. But it's also at this time, I've covered all the main information, so if you have other things to do, you can take off. You won't hurt my feelings. I'll have an attendee list. You can look for this seminar at the Predictive Engineering website. In the AVI file, we'll have this PowerPoint within it, and my little useful things with FEMAP, and I'll have the files that I use for this presentation. And I'm clicking on the questions here. I'm trying to figure out, why, See, so I still see we have 26 people hanging on, waiting, see if there's any questions. Maybe not. Good. Well, expand or collapse? I'm trying to see. Well, of course, you guys know. You can send me an email with questions. I'm happy to answer them. So I'm going to close this out. I like being punctual. I want to make these things so they're easy to get to. And if you have any comments, questions, complaints, send them to me. I'll try to make the next one better. Also, I'm looking for topics for the next one. I have ideas of what to do, but I'm doing these for the FEMAP community, so I'd like to hear from you guys what you would like to do. Okay. Have a great day. Thanks for attending. I'm going to get out of here. Bye-bye.